So we did complex numbers just a little bit when we were solving with the quadratic formula. That's when we got the I. Do you guys remember having some answers that had I in them? Do you guys remember which answers had the I in them? Negative underneath the square root. That's the issue, right? So we're going to say that I is an imaginary answer, and it specifically happens when you have a negative under a square root. So if you have an I all by itself, that happens when you have the square root of -1. That's what an I all by itself means. No number with it, just a plain I all by itself. All right? Now, because of that, if we have an I squared, that means that we had a square root of -1 that is being squared. So what happens if you square a square root? If you square a square root, they cancel out. Squaring a square root is going to cancel out the square root. Does that make sense? It wouldn't be +1. It would just be -1. Yeah, so I squared is -1. Which is weird, but it's how it works. So for imaginary numbers, I all by itself is just a -1 underneath a square root. I squared is -1. And these are the important things we're always going to remember about imaginary numbers. Okay? Now, complex numbers, so this is what we just did was imaginary numbers. I should have written it above what I just wrote. Imaginary numbers. So we learned two things about imaginary numbers. Now, specifically for complex numbers, they are written as A plus BI. So A is the real part of the complex number. BI is the imaginary part of the complex number. So if you think about if you knew a person and you would say well, they're kind of complex. It'd be like, they're sometimes real or sometimes fake. That's kind of how complex numbers are as well. They're partially real and partially fake, and that's what makes them complicated. Does that make sense? So it has a real portion and an imaginary portion, and even though it feels weird to write something that feels like a variable second, like normally we're used to writing 2x plus 5, if we were to write an imaginary number, we would say 3 plus 2i. It is proper to write the real number first and the imaginary number second when we're putting a complex number. Real parts go first, imaginary parts go second. Now, this is considered to be one number. It just has two portions to it, so it's one number. So you will often see that these have parentheses around them. A real number portion, an imaginary portion. The I is a what? It's not like an X because it's not a variable. It is just something that tells you that this number right here is fake.
So would that whole thing be in parentheses?
This whole thing would probably be in parentheses. Now, if I just write down one of these, I wouldn't put it in parentheses because it's just one thing. But if I wrote down more than one of them, if I was taking one complex number and adding it to another complex number, then I would put parentheses around my first complex number and then a plus sign and then parentheses around my second complex number just to show that there's two different numbers being added.
Example could be x plus 8 imaginary?
So the way that they would write this, they would say maybe 8 plus 3i in parentheses. Maybe subtract 7 plus 4i, also in parentheses. And that would be one imaginary number subtract, or one complex number subtract another complex number. Yeah, and we'll do problems like that. They're actually very easy to work with. Yeah. So the reason that we are interested in imaginary numbers is because of what we just learned with the quadratic formula. Sometimes when you're working with a problem, you end up taking the square root of a negative number. And it's nice if when you take the square root of a negative number, you don't have to just stop and be oh, I can't do anything. All right, so let's go ahead and do some problems with this just so we can make sure we understand how it works. If you guys are going to be giggly, I'm not going to let you sit together. Can we handle it? Can we handle it? Okay, so here's our first example, and you guys are already going to know how to do this because we've done something like this before. The square root of -9. What do I do with the negative?
You gotta take it.
Plus it.
Make it positive.
Add an I in front of
Stick an I in the front. And what is the square root of 9? 3. So this answer is just 3i.
it. So it doesn't go in the front.
It goes in the front if it's a radical. People would typically put the I in the front of a radical. So that's a square root sign. We call it a radical. If you can square root the number, then you would put the I after the number. So that's just, and I'm not gonna laugh in your face if you do it differently, but if you write I3, people are gonna look at you like you're a weirdo if you do that in later levels of math. In this level of math, they'll just be like, oh no, we don't really do that. In later levels of math, they'll make fun of you for doing it.
You can still do it though.
I mean, it'd be like if you spelled your name backwards. Like, you could do it. It's weird,
I mean,
but you
like,
could do it.
Like, just say you randomly forgot, and they'd be like, "Oh, why'd you put it in front of them? Because I wanted to. Like, this was better."
I mean, you could do it. Okay. All right, let's do another one. So this is a great question. The question was, should we put a plus or minus in front? Listen carefully, guys. This is a great question. Should we put a plus or minus in front? And the answer is no. So if you are solving a problem and you are the one who puts the square root in because you are solving the problem, then you should put a plus minus. Or if you're using the quadratic formula and the quadratic formula has a plus minus, you should put the plus minus. But if the problem is already written, then the problem already knows if it wants the positive version or the negative version. So this problem was already written. It was already written as the positive version, which means the positive version is the only version they wanted. So that was a really good question. We want to make sure that we differentiate between those two ideas. Okay, let's try another one. So we are going to square root -5. If we simplify this, what do we get? So you can simplify it, but the square root of 5 is not a perfect square, right? So we're not going to actually do that. But we do have to fix it because we have a negative underneath the square root.
Wait, so why can't you have a negative?
You make it positive with an I.
So we're going to make it positive. We're going to stick an I in the front. And so this is just I root 5. So we couldn't do anything with the number because it wasn't a perfect square. But we did need to fix that it had a negative underneath the square root. We could fix that.
Yeah, but why do you have to?
You have to fix it because it's about being proper. It's kind of like punctuation for math. It's like if somebody wrote a whole run-on sentence and had no commas anywhere, no punctuation anywhere, an English teacher would be like cringing when they see that. They'd be like, oh, you have to go and like put some commas in there, put whatever in there so it's easier for somebody to read and interpret what you mean. Here, you put a negative underneath the square root and people look at that and they just go like, you can't square root a negative. If you put that and you have an I there, then they go like, oh, it's an imaginary number. So you are doing that, so you're making the interpretation so the person who's looking at it doesn't have to, because you're doing it. Yeah. All right. Here, let's look at another example. We're going to do negative square root of 64 plus square root of negative 64 minus square root of negative 16. Okay. So we have to be careful with this one because I'm putting a lot of negatives in there to make you think about it. Yeah, what is the difference? Okay, so if we look at the first piece, is the first piece going to have an I? No. So what is the first piece?
4. That'd be negative.
-8. Okay, the square root of 64 is 8, so this is just -8.
I'm so sorry. I thought that was a 16.
There's a 16 over here, though. That's what you were thinking of. That's what you're thinking of. Okay. plus, all right, and then what about this part?
Square root.
So this is an I,
No. 8. Yeah,
8. Okay, so plus 8I, okay? And then what do we have for this? Do the negatives cancel out? Negative cancels?
Yeah.
Do these negatives cancel? No. The negatives do not cancel because what does this negative actually mean?
I squared negative.
No, it does. They don't both mean I's. What does this one actually mean?
I.
This one means an I.
And that's just a negative.
This one's just a negative sign.
Be negative and equal.
So it'd be negative
Negative
4I. Whew. Okay, so we had to be careful not to move too quick on that one. So the negatives did not cancel out, and the reason was this negative did not mean negative. It meant it was imaginary. It meant that there was an I. The negative in the front did not mean imaginary. It meant that the answer just needed to be negative. Okay, see the difference between those two negatives? Okay. All right, now let's go ahead and simplify the problem a little bit. We're going to put our real numbers together. We're going to put our imaginary numbers together. So we only have one real number, so we just have negative 8. And then what do we have for our imaginary numbers? So it gives you positive 4i. So we ended up with a complex number, and the complex number is negative 8 plus 4i. It has a real portion, it has an imaginary portion. All right, how do we feel? Make sense? Yes. We can't simplify it. This is as simple as it gets. So even though both of these are like divisible by 4 or divisible by 2, we can't do that. That would be like saying to a person who's 25, like, oh, I can simplify your age down. It's divisible by 5, so you're actually 5 years old, not 25. Like, you wouldn't do that, right? It doesn't make sense to do that. So here, we only simplify things down if it's actually like a fraction, or if they told us to factor this, we could factor it, but we wouldn't just look at numbers and say, like, oh, there's something in common, we could take something out. But you're right, that is something that a lot of students think to do. We just wouldn't do it in this situation. Does that make sense? Okay, so we're going to leave it just like that. All right, let's look at another problem. So for this problem, we're going to start actually doing some operations with the complex numbers. So by operations, I mean like adding them together, multiplying them together, subtracting them. So here's what we're going to do first. We're going to do 4i multiplied by 7i. 4i multiplied by 7i. So if you multiply those together, what do you get? We get 28i squared. Okay, 28i squared. And I have to look back up in my notes because what is I squared?
Negative 1.
I squared is actually negative 1. So this is actually not an imaginary number. This is actually 28 times negative 1. So I squared is negative 1. So that number is actually not imaginary. It's actually just what? It's just negative 28. It's just a real number. So apparently, two imaginary numbers multiply to a real number. Yeah, that's weird. All right, let's try another one. Okay, let's do negative 4i times 2i times negative 9i. Ugh. Okay. Do you guys want to multiply all three of them together, or do you want to do the first two and then multiply it by the third one? First two? Okay. So when we multiply the first two, what do we get?
Negative 8. No, 8.
I squared.
I squared, okay. And negative 8i squared is actually positive 8. So that was actually negative 8 times negative 1. So now we've got positive 8. I'm going to drop down the negative 9i and drop down the negative 9i. So now we have a positive 8 multiplied by a negative 9i. And what does that give us? Negative 72i. That's all you get.
I thought you couldn't multiply like things together.
You can multiply anything. You can't add unlike things, but you can multiply anything you want. Yeah. Okay? Okay, this one, 2i to the third times 5i. Anyone have any ideas? Oh, get it? Anyone have any ideas? No? No? Pretty good? Pretty good? All right. This is going to be an I to the fourth. So do you guys want to multiply it all together first, or do you want to kind of pair it off the way we did with this one?
I got a question.
Multiply it all?
Can we just like save the 3 for later and then take the 2 and the 5 and put them together and then put the 3 back?
So we could do that. We could, so you're saying like kind of deal with the numbers first and then save the i's? Is that kind of what you're saying?
So do 2i times 5i and then bring in the 3.
Well, the 3, so the 3 means that it's 2i times 2i times 2i. That's what the 3 means. Yeah. So we have a lot of different options for how we could do this, right? We could multiply all the 2's and the 5's, and we could kind of let the i's hang out and deal with them later. Or we could keep the i's in the problem, and we could do like these 2 as a pair and those 2 as a pair. Or we could just kind of multiply everything at the same time, multiply all the numbers, multiply all the i's, and get like one big answer, and then deal with it. You want to do the whole thing all at once? Okay. So 2 times 2 times 2, 8 times 5, 40. Okay. And then I times I times I times I to the fourth. Okay. Now, we don't have a shortcut for I to the fourth. We know what 1i is, and we know what I squared is. So what we need to do is we need to take I to the fourth, and we need to break it up either into an I or into an I squared. Okay? Now, what I would do is I would take I to the fourth, and I would break it up into I squareds. How many I squareds do you have in I to the fourth? 2. So I'm going to think of this as 40 I squared, right? I to the fourth is I squared. Okay? So the first I squared is a negative 1. The second I squared is a negative 1. The first I squared is a negative 1. The second I squared is a negative 1. So what does it give you? Wait. Does it give you negative 40?
Oh, no. Positive.
It gives you positive 40, yeah.
Wait. What's going on?
So I took all my i's.
Wait, so it'd just be 40.
Uh-huh.
So you just divide the i's?
I split them apart. I wanted to see how many negative 1s I had.
So if you split the i's, do you have to split the other side too? Like real numbers too?
Well, this didn't have any real numbers. It was just all imaginary numbers all multiplied together. So I looked at the 40. I had an I to the fourth. And I said I to the fourth is I squared times I squared. And I was doing that because I wanted to see how many negative 1s there were. And it was negative 1 and negative 1. There were 2 of them multiplied together, and it was nice. They canceled each other out. So my final answer is 40. Okay. All right. Let's see.
Say, for example, you forgot your little shortcut for the I squared. How would you remember that it equals negative 1?
The way that you remember that it equals negative 1 is exactly this. You would say I squared. You have to remember I is the square root of negative 1. That's just like the definition. So if you can remember that I is the square root of negative 1, then if you square both sides, that's where you get the definition of I squared. Yeah. Okay, let's try... Let's try some like this. We're going to try adding and subtracting some complex numbers. So let's say I have 15 minus 8i. This is one complex number. And I'm going to subtract off another complex number. So I've got one complex number and I am subtracting off another complex number. So this is going to go along with what Garrett was saying. And Garrett was saying we have to work with like terms, right? When you're adding and subtracting, you have to do like terms from like terms. So when we're doing the subtraction here, you're going to have to subtract your real numbers from a real number and an imaginary number from an imaginary number. Okay, so I'm going to start with, I've got the 15 minus the 8i. I don't really need parentheses there. The parentheses are only there because it's just one complex number all by itself. And then I'm going to be subtracting off a real number 9 and subtracting off negative 3i. So minus makes a plus 3i. And now if I work with my like terms, what is my real number going to be? 6. And what's my imaginary number going to be? Negative 5i. It feels like we're working with like regular polynomials from back in like Math 1 or whatever. It feels like we're working with x's and stuff and combining like terms. And we basically are, except we're working with imaginary numbers instead. Same idea. So 15 minus 8i minus 9 minus 3i is 6 minus 5i. Nope. Because we didn't multiply it. If we had multiplied it, we would have had an I squared. Okay? Let's try another one like that. Negative 8 plus 7i minus 3 minus 2i. Alright, I want you guys to figure this one out. Yeah.
I think that's like one of the problems. Like, I feel like I remember a problem like this. Like on my Math 1 exam. And I only saw one of them. And like, I didn't like that. I think I got it wrong because like I forgot that you needed to multiply the negative.
Yeah, distribute the negative. Yeah. Yes, I have students who still miss that in like Math 4 and pre-calculus. Yeah. Distributing the negative. Yeah. Huh? What'd you say? Not square root, she said distribute the negative. So students will often remember to minus the 9, but they'll forget to distribute it to this.
Tell me how I got a 90 on it, or it says I did, but it also says I got a 3. That's my bad.
Because it's like.
It's there, yeah, there's what your actual grade was, what you actually earned, versus the curve that you got.
Yeah, my curve that went up to 100.
All right.
Like a high 4.
What did you guys get? Anybody want to share what they got?
So I got a 3 and I was correct.
I got a 4.
What did we get? Negative 11 plus 9i. All right. We good? Negative 11 plus 9i.
You didn't do the parentheses.
What parentheses thing? The what didn't have parentheses? Oh, I just didn't show work.
Why did Miss 8 quit? Fifth period.
So negative 11, positive 9.
Oh, okay.
Okay. All right, let's try a multiplication problem. So for this one, we're going to have 4 minus I times 9 plus 5I. So I can tell that this problem needs to be multiplied because there is no operation in between the parentheses. They're written right next to each other, and if they're written right next to each other, it means they have to be multiplied together. So I'm going to do 4 times 9, which is 36. 4 multiplied by 5I is 20I, okay. Negative I multiplied by 9. Negative 9I, very good. And then a negative I multiplied by a 5I. Negative 5I squared. Okay, I need the back group, I need you guys to not sit together because I did explain it before I got started. Okay, so the 3 of you go back to your seats. Yep. You've also been very whispery and giggly and chatty and whatever. Yes. So you can multiply using the box method, yeah? Is that how you guys are used to multiplying? Did you multiply like that with Mr. Boyette?
I had Mr. Coquette as my math teacher.
So you can multiply using a box. This method, some people just say multiply, but some people call it the FOIL method.
Wait, are they doing this because there's no symbol in the middle?
There's no symbol in the middle, which means it's a multiplication problem. Anytime things are written right next to each other like that, it means they're being multiplied. Yeah. So if you like to multiply by using a box, you can use a box for sure. Yeah.
So like the other one, can we just like leave the square to?
So
Oh, wait, no, 'cause you can just
the squared, we always have to take care of it because what does a squared mean? What's an I squared? An I squared is a negative 1.
just be positive.
So the negative 5 is actually negative 5 times negative 1. And so it's actually a positive 5. So if we combine our like terms, we have a real number 36 and a real number 5. And what do we get? We get 41. And then we have an imaginary 20 and an imaginary negative 9. Positive 11. Okay. Negative 6 plus I plus 3 minus 9I. Is this a multiplication problem? No. How can you tell? It's got a plus in between. So you always have to be careful to look in between to see if they're right next to each other or if there's something else that they're telling you to do. So here, when there's a plus sign in between, the parentheses are really unnecessary. And Ryan, the only reason they have them, thank you, the only reason they have the parentheses there is to tell you that this is the first complex number and this is the second complex number. But we don't really need them because we're not really distributing anything with our parentheses. So whenever I see a plus problem, an addition problem, I always just rewrite it without the parentheses since they're basically unnecessary. And then I go ahead and I just combine my like terms. So what do we have for our real number? We have negative 3. And then what do we have for our imaginary number? So are we multiplying or adding? So what do we have? Negative 8i. Perfect. Yeah, once you get to the point where the i's don't feel weird anymore, they're actually not bad. Okay. Let's do negative 4 minus 7i squared. Negative 4 minus 7i squared. So what does the squared mean?
It's multiplied by
Is it everything? Because I heard two answers. So one answer was we just square everything inside. The other answer was we take the parentheses, we write it twice. Which answer is correct?
my answer.
Shoes on.
Take the parentheses and write it.
So we have to take the parentheses and write it twice. We can't square everything inside because of the minus in the middle. If this problem was written as negative 4 times 7i squared, then you could just square, they're not the same thing, then you could just square everything inside. Because this is multiplication, and this is just telling you to expand multiplication. So if it was an expansion of multiplication, you could just square it, you'd be good. But this is addition or subtraction, and you can't expand addition or subtraction using an exponent. So with this, we actually have to write it out twice and multiply it. And the reason is if you just square the first term and square the last term, you'll end up getting this part and this part of the answer, and you will miss out on these middle terms, and your answer will be wrong. So we're going to take this, we're going to write it twice. Negative 4 minus 7i, negative 4 minus 7i. And we can do the box, or we can do this method up here. This is kind of like the FOIL method. What would you guys like to do? FOIL? Okay. Full if you're from the South. Okay. We're going to do the full method. So we've got the first times the first, which is what? 16. And then we've got the outsides. Negative 4 times negative 7i. Negative 4 times negative 7i. Plus 28, perfect. Plus 28i. The insides, negative 7i times negative 4. Plus 28i. And then the last is negative 7i times negative 7i. Plus 49, 7i, I squared. Okay. All right, so we're good with these parts. What do we have to do with this part on the end? I squared is negative 1. 49 times negative 1. Negative 49. Okay, so we have a positive 16 and a negative 49 for our real number. Positive 16 and a negative 49. Negative 33. And then we have a positive 28 and a positive 28 for our imaginary. 56. Okay. Okay, I'm going to give you a kind of weird one. Not super weird, just a little weird. This can be, we could do this as the last example. Perfect. Okay. So they're written next to each other. So we have a real number times an imaginary number times a complex number. Real times imaginary times complex.
Would it be like negative square root of -1?
So, yeah, so could we multiply these two first and call this negative 2i? Okay, let's do that. So I'm going to call this negative 2i, and then I'm going to multiply it inside the parentheses. Does that make sense? Okay. So we'll distribute it inside negative 2i times negative 1 is positive 2i. Negative 2i times 3i
I keep forgetting that one.
You're good. And then a negative 6 times a negative 1 is a positive 6, okay? Now, should we write 2i plus 6? 2i plus 6. Is that how we write the answer? No. How do we write the answer?
6 plus 2i.
6 plus 2i, because we always put the real part first.
Whoa, I just said something.
It was negative 6 up here, but we multiplied it by a negative 1 when we fixed the I squared.
Would I get the problem wrong if I put 2i plus 6? Really?
Yeah.
That's so cute.
It'd be like if somebody always spelled your name backwards. You'd be like, that's literally a different name. That's literally not my name.
That sounds weird.
I know, right? Yeah, it'd just be weird. Yeah. All right, I'm going to give you guys a couple of these for homework. Woohoo! Yeah, write your name backwards.
Wait, is your name Anaya? Are you the one I texted that? Oh my god. I accidentally texted her. So it's like, bye.
I run,
I say that to my dad too.
Terray Kasarum.
What are you doing?
Huh? It's my first and last name.
Okay. And you have to show work to get credit, okay? You have to show your work.
Show my